Good afternoon. Welcome to PDC and welcome to our session entitled Lessons Learned, Building On-Premises and Cloud Applications with the Service Bus and Windows Azure. I'm Todd Holmquist Sutherland. I'm the man behind the cryptographic quality last name that you see floating around the Windows Azure scene these days. And you will see me breaking the mold of every attendee list you've ever seen. So I'm really the bane of the existence of these kinds of events and the planners that work on them. I'm actually a group program manager at Microsoft in charge of what until recently was known as the .NET services. Many of you are aware that a year ago at PDC we announced and launched the .NET services, which consisted of the Service Bus and the Access Control Service. A couple of days ago, Bob Muglia made the announcement that that was going to be rebranded, and so now we are called the Windows Azure Platform App Fabric Service Bus and Access Control. Good luck remembering all of that. I'm going to do my best, and if I slip, I apologize. Today we are going to be walking through some examples of customers who have been early adopters who've been working with us over the last year to use the Service Bus and Access Control Service to build what we're calling hybrid applications, which mean applications that span the cloud and on-premises hosting environments. We have learned a lot in that process of working with early adopter customers, and we thought the best way to illustrate for you some of those lessons we've learned was to actually to ask a couple of those customers to come up on stage and tell you directly about the experiences they've had and some of the innovative and interesting things they've been doing with the Service Bus and the Access Control Service. Briefly before we launch into that, and the bulk of the session is going to be divided up amongst the two customers who have come here today. But I'm going to set the stage just a little bit by talking about some of the scenarios that we've observed from the product group that are quite common scenarios that customers face when building hybrid applications. And one of them is, even if you take a look at the very simplest application that you move into or build for the cloud, a simple standalone web app, it's quite common for customers to have a desire to message into that application from their on-premise data centers and to not necessarily have to write web services in order to enable that messaging. So, for example, if you have worker roles as part of your web application, you have a problem of how to address those worker roles. If you want to configure them in real time, or if you want to stream data into those worker roles for some sort of processing, or if those roles need to reach out and grab data from an on-premise data store in some way, shape, or form. So messaging into worker roles and messaging out of worker roles can be a challenge. We've seen a lot of people leveraging the Service Bus and the Access Control Service for that. We've just had a presentation just before by Matt Winkler in which he talked about monitoring out of the using the Windows Azure monitoring agent to monitor applications running in Windows Azure. And that's certainly a very useful tool. But if you wanted a real-time stream of monitoring data, you would need another approach to solving that problem. And we're going to hear from a couple of guys today from Active Web Solutions who have solved that problem using the Service Bus and Access Control Service and done it in a very elegant way. Moving beyond the very simple standalone web app scenario, there are many more challenging hybrid scenarios that customers often encounter, which is in the case where you may have multiple different locations that you need to interoperate with from the cloud. So you may have a cloud application that needs to talk back to components or technology assets that are resident inside a corporate headquarters. That cloud application may actually need to talk to multiple different subsidiary organizations, each with their own networking environment and their own firewall and NAT complexities that can get in the way of those types of communications. We also see customers who are building software as a service applications and hosting them in Windows Azure, and then have a desire to integrate with data or application components that are resident on the customer location. And of course, those SaaS vendors don't want to have to ask their customers to make special modifications to their networks in order to integrate with that SaaS application. So the Service Bus is really the key to enabling those scenarios, and the Access Control Service helps in the sense that it makes it possible to lock down those communication channels and ensure that only authorized parties have access to them. So as together, these two components are a really powerful tool for enabling those types of hybrid scenarios. And then the last one I've got up here, I called it Extreme Sport, which is Internet Scale Pub Sub. We're going to see another example today of a scenario where multiple industry participants need to share common streams of pricing data, and they need to do it from multiple locations with different types of identity being used to secure that access to that data, and different types of network configurations that need to be traversed all seamlessly in order for that data to flow through the system and for all of the participants in that network to benefit from that data. So those are just a couple of high-level comments about what to look out for, and some of the things that we've learned as we've watched customers use these services we've built, and some of the patterns that we've seen that customers are embracing for solving the problem of building hybrid applications. So without further delay, I'd like to bring up our friends from Active Web Solutions, who've come across the pond to demonstrate for us the sea safety system that they've built and some other interesting apps that they've got going. Welcome.
Great, thanks very much, Todd. Everybody hear me okay? My name is Richard Prodger. I'm the only one mic'd up here, so I'll introduce Rob. I'm the technical director at AWS, and Rob's our R&D director. And what I'm going to talk to you today about is a system that we've been developing over the last few years with the UK Search and Rescue Services, which are known as the RNLI, or the Royal National Lifeboat Institution. AWS is a boutique software house, smallish company, but the RNLI are responsible for all of the UK search and rescue around the coasts of the UK and Ireland. When I was putting this deck together, I did wonder whether I should put this slide up, because I was half expecting a mass exodus of people thinking, well, seeing that slide, am I actually in the right room, or am I at the right conference even? But hopefully when I explain what this slide is about, it'll all become a bit clearer. We were approached by the RNLI about 4 years or so ago to assist them with a challenge that they had, and that was we lose about 30 or so fishermen a year, commercial fishermen drown off the UK coastal waters. And they disappear because they fall overboard, or the boat turns upside down. A lot of these guys, because of commercial pressures, fish single-handed. And there's a commercial fleet of around 6,000 or so vessels in the UK. And they asked us, could we come up with a technical solution to that? To cut a long story short, we built a system which is known as MOB Guardian, or Man Overboard Guardian. And what that system is a small box of electronics that gets installed on a fishing boat, and the guys wear a small wireless pendant around their necks. And if they fall over the side of the boat, then a signal is sent via satellite directly into the search and rescue headquarters. Now, we built that system, and it's an on-premise system. Thank you, sir. We built that system, and it launched in January of last year, and I'm really pleased to say that so far we've saved 9 lives, which is great. And it's continuing to, thank you. And it's continuing to protect the UK fishing fleet. But what the RNLI came to us and said, well, you know, this is great, we've done this for the UK now, and the rollout is taking place. There are an awful lot of other people around the world that we could protect with this system. The International Labour Organization, for example, has estimated there are 24,000 deaths just in commercial fishing alone around the world. There are other markets. There are 500,000 leisure boats in the UK, 8 million in Europe. So if we could come up with a system that could scale out to address that kind of market, then we could save an awful lot more lives. So that was the challenge that they set, or we indeed set ourselves. And we looked at our on-premise system, and we decided that, yes, we could rubber stamp that out around the world, but we'd have to put more tin into more data centers in different places. Then we were introduced to Azure, or Red Dog as it was, prior to PDC 08. And we built a proof of concept to try and understand, could we scale out our on-premise system? And we've built that now, and over the last 9 months, as Todd alluded to, we've developed this system, and we now have, which is actually running in parallel with our on-premise system, is live as of the launch of Azure today, or yesterday as it was. So we built this thing, and and I'm not going to go into what Azure is all about and how that works and why that provides scale out. I mean, most of you will have been to sessions that have explained all that. But what I did want to talk about very specifically here is what was it about Azure Compute and Storage that couldn't satisfy some of our requirements? And Todd mentioned this at the beginning. One of the things we absolutely had to achieve was the ability to talk back from the cloud back to on-premise data that was static and couldn't be moved. This system is a confidential system. And alerts are only raised when a fisherman is in trouble. They don't want to tell people where they're fishing, so we have to keep secure on-premise some data. And the RNLI are not yet ready to move that data into the public domain, so we had to keep or into the public cloud, I should say. We had to keep that on-premise, so we needed to do that. We also want to be able to route messages, alert messages from our cloud-hosted system into other search and rescue organizations when we don't want to have to interrupt their IT infrastructure, so we wanted to find mechanisms for punching through firewalls and getting messages into their systems. Fundamentally, though, and this is what we'll come on to in the demos in a little while, is we wanted to find a mechanism for remotely managing. I don't know how many of you were in David's talk prior to lunch in this room when he talked about the Azure logging APIs and so on, and some really cool stuff that you can do there. And that's great, but we need to do that in real time. This is a safety of life system. So when one of our modules running in the cloud or one of our instances in the cloud throws an exception, we need to know pretty much instantaneously. Even if we had minute-by-minute logging into TableStore and pulling that data out, that really isn't fast enough for us. And we also wanted to be able to control the applications as well remotely. So we'll have a look about how we did that. So we've got this big distributed infrastructure, which is, because it's safety related, we need to make sure that we're managing that properly. It's not like, okay, if you go to an online shop and your transaction fails, people don't die as a result of that, not generally. This maybe the sales manager might, but. Okay, so it's a bit of a pun or play on words really here, the service bus to the rescue. We were first introduced to the service bus, and I don't know how many here are familiar with the service bus or the whatever Bob Muglier calls it today. Okay. So it's a mechanism really, we describe it as a big infrastructure plumbing kit. It's a means by which we can send, route, and queue messages between two endpoints, essentially, whether they're in the cloud, on-premise, between on-premise and on-premise, premise and the cloud, all possible combinations. And what it allows us to do is it allows us to really easily distribute messages from the cloud to on-premise without having to worry about getting the IT guys involved and opening up firewalls and pushing those messages through, and then the potential security risks that are involved with that. As I mentioned a moment ago, it's really easy for us as well to be able to integrate new search and rescue customers, because with their legacy infrastructure, we can't go in there and insist that they change what they do. So by using the service bus, we can tunnel those messages through. And one of the other things that we've achieved, and we'll demonstrate in a minute, is how we can surface from within our cloud-hosted infrastructure now core information about what's going on in our applications. If we hadn't got the service bus, we'd have had to have built a lot of this stuff ourselves, and it would have cost us an awful lot of money, an awful lot of time, and it probably would be nowhere near as good. Okay, this is a bit of a fussy slide to read, but it's just to kind of summarize what we've done. The blue blob at the top really is supposed to represent the Azure infrastructure as a whole. We can take messages in from a variety of different devices, the MOB Guardian device itself, but we can also, this is a generic platform, we can take messages from a variety of other geo-aware devices, GPS-enabled devices, and so on. And we put that into our infrastructure. We process those messages, determine which of those are alarms, and then we route those messages over the service bus. On the left-hand side, at the bottom there, where the firewalls are, that's an element which we'll talk about in SNMP proxies. Anybody here familiar with Simple Network Management Protocol? Yeah, a few hands going up. Okay, I don't need to explain that in great detail, but we'll come on to that. But we can punch messages through to management systems, we can punch through to on-premise data, and we can route messages on the far right-hand side there. We can route messages through to search and rescue services. So what we're going to do is we're going to go straight into a demo, and Rob's going to help drive the demo here. There are two key elements of this application that we're going to share with you. One's this trace listening capability, and the other one is tunneling. Okay, Rob, so one of the things we need to do is we need to be able to get live information. David talked earlier about the ability to take trace information out of the cloud and store it into TableStore. What we've actually done here is we've built a trace listener, which you can just add to your web config or your app config inside your Azure-hosted instance. And what happens here is that information is now routed via the service bus. So Rob's just initiated a very simple console listener that's listening to that information coming out of the trace. And what's actually happening here is the messages, we're doing a standard .trace.writeline or trace information in code, nothing different there. The trace listener's in the app.config. That information with this code is then being routed through the service bus, coming through the firewalls here and straight onto the desktop, onto the laptop here. We didn't have to do anything, no reconfiguration of any of the elements of the system. And that's cool. The code for this, by the way, is up on Codeplex if anybody wants it. But I'm also pleased to say that as of the latest November CTP of the service bus, they've included the code for doing this in the samples. So if you want to do this for yourself and actually trace information from your own applications straight down to your desktop, then there's an example there of how to do that. So that's okay. So we've got this information. This is basic information that's coming through from the service bus. But what we want to be able to do is we want to be able to control what's going on in the cloud. So we've built inside our application an application server capability on top of the role instances. So now we have the what we wanted to do is we wanted to maximize the CPU usage, if you like, of each role, because you've got to pay for them at the end of the day. Let's be clear about that. So rather than having multiple instances when we don't need them, we created a multi-threaded application framework that sits inside a role, which allows us then to scale our application up. And when we run out of CPU on one, we can start another instance. So we wanted to have the ability to control that and control that information in real time. So we looked at what was out there already, and there are a number of solutions potentially here, but we decided to opt for the simple network management protocol approach because that's standards-based and because an awful lot of network management systems out there already support SNMP. We thought, well, why should we go invent another one? So what we did was we built an SNMP agent which runs inside of your Azure hosted instance. And Rob's just showing you the client end, or the proxy end of that, if you like. So we have a proxy running on somewhere on your internal network, in this case on the laptop. And that's proxying and essentially tunneling SNMP messages via the service bus into the cloud. So in the SNMP world, what happens is you have two basic functions. You have what's called a get function and a set function. With a get function, you can send a message. You go and send a get message to an object. That object can be anything of your definition, and then that will return a value. And similarly, you can send a set message to change the value of an object. So we have a very simple SNMP assembly, which you just reference in your code. And then if anybody wants to figure out how this is done, I can go and show them. It's very simple. And you can just register an endpoint, if you like, inside your application and say, respond to a get message, and then return this value. So that's what we've done with this agent. And what Rob has got up on the desktop there is what's known as a MIB browser, which stands for Management Information Based Browser. And this is just sending, or a very simple network management tool, if you like, that allows us to send get and set requests. So on the left-hand side, you can see a tree structure of elements, objects, if you like, which exist in our domain, in our application domain. There are some standard ones that are available. So the one that Rob's pointing at the moment, sysuptime, that is a standard, they call them OIDs, object identifiers, standard elements, if you like, which, if you implement an SNMP agent, you must create. So sending a get message to that, Rob, if you could just click on the go there. And what comes back is the uptime of that instance, that role instance that's running in the cloud. And that we restarted the role instance just a few minutes ago, and that's coming up, so it's telling us 5 minutes. So I've got real-time information about what's going on. So if you say select the, I don't know, Rob, choose the name, that's now returning the actual VM machine name that instance is running on. Now you can configure this to do whatever you like. Our code that we've got for this is just, you just register a method to call when you receive that message. So you can essentially return and do anything you like. So if we look down a bit further down the MIB tree there, we're going to have a look at hosted services. Now one of the things that we also want to do is we want to be able to control start and stop instances. So if we have a peak load of messages coming in via the satellite infrastructure, we might want to grow the number of instances we currently have running. And we need to do this in real time. So if you click on go on that, Rob, what's actually happened here is a message has been sent to using the service management API that's now available. And what's come back is a list of the deployments that we have, the hosted services that we have. And we have two there. The top one, which says GeoPoint LBS, is our live platform. And the PDC demo one a bit further down is the one we're currently using now. So if you click go again, Rob, on the deployments, And what's going to come back from that is you can actually see there a production. There's only one deployment in there, a production one, and that one is currently running. And you click on Roll Instances, Rob, and click Go. So we're sending these GET messages across the network. And what's coming back here in this case is we've got a worker role running, which is where our web services are, which is where our main processes are, and a web interface running inside a web role. So that allows us, this browser here, this MIB browser here, knows absolutely nothing about Azure, knows nothing about how we're communicating. It's just sending SNMP messages out. So if you have a network management system, whether that's HP OpenView, some open source one, or some other device, then you can use that as the means of communicating through the infrastructure. One thing we'll just finally do in terms of controlling things back the other way, if we just set the logging level, for example, that's one value. If you go and get that, Rob, it's currently set to 31. This is how many tracing messages are coming out. If I change that, Rob changes that, say 15, Rob, I can actually turn off. If you look at that trace window now, you can see the tracing has stopped, and we should only get a heartbeat message every 10 minutes. So I can get exceptions coming out of my application, I can trap trace information, and I can control the processes going back the other way. So that was kind of it. If you want to find out a bit more, as I said, socket shifter, that's the technique which we use for communicating back to on-premise SQL databases. So a TCP/IP remoting capability. You can have a look at the MOB Guardian website if any of you are fishermen and want to buy one of these pieces of equipment. And there's a case study just been published as of yesterday that explains all this system. But we'll be down in the booth in the lounge if you want to come and find out some of the details a bit later on. Thank you.
Thank you, Rob and Richard. Thanks very much. Rob and Richard both promised me that no actual fishermen were hurt in the making of this demo, so I'm comforted by that. Although I think they did take a couple minutes to get the right pose before they tossed the rope in the water when that guy was. Okay, I'd like to invite up our second customer who's agreed to come talk today, Invensys, represented by Paul Forney here, and we also have Alexei Savatayev from Microsoft, who's going to show you a demo of some smart grid infrastructure that they've been building. Take it away. I've got your slides here.
Oh, you have them right here?
Yeah.
He's got this one too.
You can use this controller. While these guys are getting set up, let me just comment that as we've been working with customers, we've noticed that there are sort of three broad patterns in use out there in the field. And one is the eventing pattern that Richard and Rob were demonstrating of sending log data in a unidirectional way over the service bus in a way that traverses firewalls. Another common pattern that we've seen is the tunneling scenario that they were representing, where we're talking about taking an existing TCP protocol and simply routing that over the service bus. And the way that they did that is using something that they called socket shifter that they've built, and they've put that up there for you all to view. It's on Codeplex. But you can actually create your own type of socket shifter very, very easily. You can look at the code that they built. It's basically using a net TCP relay binding on the service bus in order to traverse any TCP-based protocol in a bidirectional way over the service bus. And so that's a tunneling pattern that we've observed. And then the last one that we see a lot of is a service remoting pattern, where someone has a service, a two-way service. Usually a service is something that's adding some kind of value or business content in response to a request. We are seeing a lot of customers use the service bus to take an existing service or to write new services that they don't want to expose publicly, but they want to expose to a limited set of partners and secure those on the service bus using the access control service and publish them in the namespace, the URL namespace that the service bus provides. So that's sort of a third broad pattern. And if any of you are interested in more details about the service bus, these patterns that I'm discussing, or anything that you've seen up here today, we're going to be at the booth right after the demo. So we'll be available to answer questions. And that includes all of the folks who are up here presenting today. We'll be at the booth for some time right after the demo. All set?
We just lost the network. a second here.
Just to talk about a little bit about this project, this is a jointly developed project between Invensys and Microsoft. And the role of my team, developer and platform evangelism, here is to help the companies such as Invensys to build the prototypes of the systems based on our latest and greatest technologies, such as App Fabric. And this is an example of such an engagement with the external customer. So we're going to showcase you how Invensys solves real-world problems with help of App Fabric, Service Bus, and ACS specifically. And also there are a couple other major components that are used here, Windows Azure and Silverlight.
Alexei, it might be helpful if you talk through a little bit the messaging flows that are involved in this application, because they're actually quite complex. There's a lot of components and moving parts.
Right. So what we're trying to solve here is basically the dynamic energy pricing scenario that is basically part of demand response scenarios of smart grid. As you might know, smart grid is a national imperative supported by Department of Energy, and it is an industry-wide initiative to develop a next-generation power infrastructure. And the infrastructure that is needed to support a smart grid is extremely complex. It needs to be extremely complex because there are literally millions of users that are participating in these scenarios. And we are exchanging millions of messages in real time between home residences, businesses, utility companies, and power generators to exchange the real-time market data in terms of pricing, power consumption, utilization. Smart meters are participating in these scenarios. And the actual infrastructure, the software infrastructure that powers it all, is based on the service bus. Service bus literally serves as a cornerstone of this infrastructure, providing massive scale with multicast scenario. For example, we're using net event relay binding of service bus that allows us to send the message once, and all of the receivers, all the listeners on specific endpoint that we declare are receiving this message in real time. It's not a loop that we're using. We're basically sending the message just once by calling a method.
Alexei, one of the things that you guys are going to demonstrate here today is the ease with which different participants in the power grid can connect and begin consuming these streams of data. Is that something you could say a couple words about in terms of the way in which the onboarding process is?
Right. I'll let Paul to speak into this regard.
Okay.
Thanks.
That's demo hell. Lost the network connection. Wouldn't be much of a demo if we didn't show you what we could do by tunneling over into our network back behind firewalls. So maybe I can back this slide up a bit here. Is that all right? Yeah, anyway, Invensys is a worldwide company, about 35,000 employees. But we have quite a few name brands of products underneath us involved in industrial automation technology. Foxborough, Triconix, SimSci-Escor, Wonderware for human-machine interface software for control systems, Advantis for asset management. But the vertical markets we serve are in refining, oil and gas, power, chemicals, and pharmaceuticals, just to name a few. So it's a very horizontal type of an application. And today we're going to be talking a lot about power. I got asked to help with this demo here. This is actually Dave Harden's work. He started this about 8 months ago with Alexei, with a vision that he had, and he's on working with the Smart Grid Council. And in fact, this week he's also presenting at one of their conventions this week. So I decided to help out with this. They kind of picked me because I had an application that I did for the power industry about 5 years ago, and we're going to hook that guy up.
That is currently using the results of this pilot application.
Right, exactly. So we're going to show you how that's going to work. But back underneath that, Orchestra is a technology from Invensys that actually propagates itself throughout most of our products. as a platform on which to build on. So it's very not unlike what you're hearing about Azure for the cloud. We're the similar type of situation for the plant floor. So where we kind of unify everything to be able to talk to multiple different devices of all different kind of manufacturers and types, to get sensor information, to do control, produce the type of things that you need to actually run a facility from all those different markets. But on the Orchestra platform, on the industry applications that build on top of this, we provide them common services like messaging, security, alarms and events, historization, very high-speed historization type things where 150,000 points a second have to be historized. The visualization, and we actually have a web portal as well to help. But as you see here, we're going to be using Orchestra in this demo here to consume information coming from Alexi's demo through the service bus, back behind a firewall, and get this stuff into a control system that's usually very much protected and doesn't, they don't expose control systems to the internet very well like that. But anyway, the application we were talking about, and we have Ken Wen here as well. He helped out on this. He was the tech lead for this application about 5 years ago, where we were breaking new ground using .NET and using what was then Live Communication Server. But we had to solve 3 main use cases, and this happened right about, remember the big blackout on the East Coast, right? So, the whole East Coast went down because of a problem, and what was that problem? It was just a lack of real-time communication between the people that run the grid and the people that supply energy to the grid. So a fault happened in a plant, and next thing you know, one thing after another, without being able to communicate back to to another plant to pick up the load, it just kind of cascaded like a big domino effect. So so a company came to us, a smaller group, that had their own grid, their own set of 10 different power plants putting information on that grid. They gave us 3 use cases to help solve this problem so it wouldn't happen to them. So we developed this application. It took quite a bit. We took quite a bit of infrastructure to get 10 plants all connected into the grid, sharing messages back and forth between them. There was actually 26 domain controllers involved in this application. Quite a bit of spaghetti to get it all to work, but it did. We had the use cases of being able to send instructions to power plants so they can pick up load at any time, a given time, and also to take information from those utilities themselves to say, how much can I put on the grid at any particular time? And the third use case that they had was to be able to cost transgressions. And that's where we're coming in today, because Dave Harden and Alexi have done in their prototype to put the pricing information for a megawatt of energy, which comes from ISOs. Today, Alexi will be playing the part of an ISO. That information comes into these type of facilities, and they can use that information to calculate transgressions in real times. How much am I going to get pinged by the grid if I don't put enough energy? I was contracted for 500 megawatts. I only put 450. Well, I'm going to get a bill. And what is that bill going to be? So we kind of picked this application to show that we could do this sort of a thing. Also, a brand new application that just released recently was a corporate energy management solution as a Wonderware industrial application from Wonderware, built on top of the Orchestra platform. It looks at the other side of the coin, not necessarily the power producers of power. It's the side the industrial plants that are consuming power. And these guys are in the range of $100,000 to $200,000 a month in their energy bills. So very small improvements in that in their consumption of energy helps a lot. So the application basically has the meter readings coming in, an application sitting on top of our Orchestra application server, and it takes energy-related events. It could be a shift, it could be a batch that was being produced, it could be some alarm in the plant, and it calculates, the energy consumption over that particular event, storing it into a database, and then allowing through our information server to produce reports and let people collaborate on ways to better improve the efficiency and reduce the waste. So here again, the marketing data information of what they're paying for a retail unit of energy has to be incorporated into the system. And then at this time, it's still a rate schedule. It has to be hand put in and actually typed into this thing. So we're going to try and look at it from a different perspective. In the end, they produce the reports and are able to, how much energy did I use for a particular batch, how much did it cost me, and what was the minimum and maximum energy cost. So today it brings us to the demo that we have now, and what the flow of this messaging is through the Azure cloud. As I said, Alexei is going to play the part of the ISO, the independent system operator, that actually has the pricing information, wholesale price that we're going to pay a generation unit, a utility to put power on the grid, and also the retail price of what a consumer would use. So as this thing flows through this system, Alexei has what we call an energy pricer that's going to take data from a regular website, publish back into the App Fabric service bus, and let that be consumed by different consumers. And in this case, we'll show it going into a utility.
And just to let you know, this is just one of the scenarios where service bus is used by this pilot application. For the demonstration purposes, we're kind of simplifying it a little bit and showing just this flow. There are a whole lot of other messages that are being exchanged. For example, the utilization information from actual smart meters installed in the homes and businesses flowing through the service bus. There's a status information that goes back to the utility company so they can observe how well the smart meters and the devices and the clients are doing in this smart grid infrastructure. And for all of these reasons, we're using App Fabric service bus and ACS to secure the message flow. And where Windows Azure comes to play is when we actually need a scale for the Silverlight clients and other clients, in fact, to be served from one single location, which is managed by the utility company, essentially. So utility company would have an account with Windows Azure and Service Bus and ACS, and would be able to essentially serve all of its clients, the utility company clients, all of you basically that are receiving electricity and water and sewage and other services from the utility companies from this single point, being the cloud, really. And on the left-hand side, on this diagram, you see the cloud parts, which is Windows Azure solution and App Fabric Service Bus endpoints that expose the services to the end users, and in fact serve as endpoints for the utility company's own services that define the prices and consume the status information and so on. And we serve the Silverlight clients from the Windows Azure solution, from the web role essentially, and the worker role hosts the aggregator for all of this information that makes certain analytical decisions about where to distribute the data, where to store it, what kind of reports to produce, and so on. And on the client side, we have energy controller and registrar clients that are needed for a system to operate. The user basically registers with the system, and that's how he starts getting to receive the energy pricing information. So just to show you how this message flow is done, the utility generates the dynamic price from the energy pricer based on the diagram that we showed you before. We get this price from the wholesale web service, which is publicly exposed real-world data right now. And through the aggregator, it flows to the web role where it's served to the Silverlight clients that are connected in a scalable way through polling duplex protocol with web role. We actually had to make a change to Silverlight 3 itself to be able to be hosted in Windows Azure in a scalable way. Otherwise, it would only work with one single Windows Azure instance. And it looks like that feature is going to make it to Silverlight 4 as well. So this is basically the way we handle the two-way communication between Windows Azure and Silverlight. So this is one of the lessons that was learned here, is that when you connect multiple Silverlight clients to multiple Azure roles, you have to basically implement your own polling duplex mechanism. right now with Silverlight 3. And with Silverlight 4, we're making it a lot easier.
Okay.
So we're going to go to the demo now.
Let's move mine first.
And Paul is going to run his portion first, and I'm going to show you the smart grid pilot application that is interoperating with existing Invensys products that Paul is going to show.
Right. Can you hear me back okay? I hope I didn't kill this. Okay, it is the PDC, so I guess we get to show some code here. But this is the first instance of it coming back in, right? So there will be, Alexi is playing the part of the ISO, publishing pricer information up into the cloud. So I'm sitting at a location of an actual power plant that's going to consume this energy. I mean, this pricing information and do calculations on it. So the work that's going to be involved in doing that is going to reach up into the cloud. First, we're going to establish communication to the orchestra message bus, which our network message exchange, certainly not on the cloud. And then we're going to new up a data feed service that knows how to connect to the cloud, and then set all the the configuration settings into that service. We'll start the data feed service, pull that information in, and then we're going to start doing some XML manipulation. Right? We'll pull in the data from one XML, move it back out of the orchestra, map it back into different points that we're going to need to use inside the orchestra application. And then sit there and wait for events. And as they change, we pull the information out and write it onto Orchestra. So let's go ahead and run this, and hopefully it will work. Now, if we pull, your pricer is running over there. Okay, there we go. So it's connected to Azure right now, and you can see it's pulling in pricing data there of $49.158. It's also determining what hour it is, so that the hour 13 would be about 1 o'clock. So we'll move over to another machine. And remember, both of these machines are back behind firewalls, or just like as they would. I'm remoted into them. So I pull up to this machine. This is where what the power plant is looking at the output of its generator. And these red points here, I've just taken a sine wave and wrapped it around my simulation generator. But I'm calculating in real time, the value of those transgressions, and I'm displaying it here. So what would it look like? How do you see that price coming in? Well, remember, normally they would be using a screen like this to input data. And I just refresh this screen. And you can see there at my 1 o'clock area, there's my $49.15 of megawatt hour that Alexi sent to me over the Azure bus. So we're going to switch back up over to Alexi and show you more on the client side of how he did this and jump into his code. Okay.
So here you see the Silverlight client that the end users will be actually using to receive this real-time pricing information to feed back to the grid the information about their consumption. So this upper right-hand corner graph, it basically shows you the pricing and the cost, the overall cost using these prices. How much would it cost the user to actually run the current electrical appliance set that he has, a home residence or a business, considering these prices. And this price is an actual retail price that we're calculating based on the real world data from the wholesale web service. So it is actually going to change. Sometimes it changes, sometimes it doesn't. Consumption is something that we are basically simulating here with absence of actual smart meter. If you have a smart meter connected to the system, then it would feed this consumption back. We also have accumulated monthly cost to date and projected monthly energy use specified here, and also status information that the user can feed back to the grid to tell the utility company the state of its client. And we're basically able to
interrupt. We're going to have to make room for the next presentation to come in. I'm sorry. But I wanted to point out that this application that these guys have written at the end here is just an example of one of several apps that have been demonstrated here, all of which are either producing or consuming the same pricing information, and all of that's being connected over the service bus. So I want to thank these guys for coming, and really appreciate you taking the time. I want to quickly mention that we have some cards by the door you can pick up, but unfortunately the mice are already out for the day, so you'll have to do a hands-on lab if you want to get a flip phone. I also want to mention that there's a couple other presentations on service bus and access control service. Clemens Vasters is doing a presentation tomorrow morning at 8:30 on the service bus, and Justin Smith is doing a presentation on access control today at 4:30. So please look for those and come by the booth if you have other questions. I'd be happy to talk further about these. Thank you very much.